Okay, so we're ready to talk about domain and range examples. We just went through how we deal with the two forms of it. So we're going to start with discrete here, and we're going to talk about how some discrete examples and how we would write the domain and range. To remember, discrete examples then are points, and you can see that example 1, 2, 3, and 4 here are all combination of points, 1 point, 2 point, 3 point, 4 points, right? And they're all grouped together, so it says this set of points, and it's asking us what is the domain and range for those points. So if we do that, remember we're using set notation, which means that we're going to separate the domains, pull them all off, write them in order from smallest to greatest, and then we're going to do the same thing for the ranges. And these are the ones you should like. They're pretty straightforward. So if we look at this first example here, here are the set of points. So if it says what's the domain of that, you write D, and in fancy brackets or set notation, you write the smallest domain that you can find, which is -2, and then you write the next one, which is -1, then you write the next one, which is 1, and then finally the last is 2. There you've defined the domain. This set of points, these 4 points, these are all the x coordinates where you can find that function. That's what we've said. All right, for the range then, similarly, I'll switch my color. You can do the same thing. So you find your lowest value of the y coordinates, and again, this is up and down, right? So this is where we can find the function -3, -2, 2, and 3, and we've listed them in that order. So these are all the y coordinates where we can find these points there. Okay, there's one key thing that we want to remember is that we don't write repeats when we do this. So on the next example, we're going to do the same thing, except for we're not going to write the repeat. So for this one, the domain, right, and here's my fancy brackets, is going to be the combination of there's a 7, a 7, a 2, and a -4. So I'm going to start with the -4 because it's the lowest value. Then I'm going to go to the 2, and then I'm going to go to the 7, but I'm just going to write it once. There's my domain, all the x coordinates where I can find these points. Now I'm going to do the range. Okay, the range I'm going to look, I've got a -2, I've got a 0, a 2, and a -9. So -9 is where we're going to start. So we're going to start with -9, and we're going to put our -2, and we're going to put our 0, and we're going to put our other +2 here. So we've accounted for all 4 of those. Is it okay that we have fewer domains and ranges? Yeah, it's perfectly fine. It didn't ask if it was a function or not. If it did, we would determine if that's function. Some of the other problems will do that. Okay, you can see here is in table form. Tables are almost set up to give you the domains and ranges, especially if it's just a set of points. In this case, it is. Sometimes these represent some points in the function. In this case, this is all of the points for the function. So there's 1, 2, 3, 4 points there. All the domains then are listed nicely in order for us, so we just write 1, 2, 3, 4, and all the ranges are also for this particular one, not always, listed in order for us as well. So there's our domain of 1, 2, 3, 4, our range is 10, 20, 30, 40. So for example 4 then, nicely, just like the last one, all of our domains then are listed for us in order, so we'll use our fancy brackets for set notation. And when you draw those, I like to make an S and then a 2. That's generally the way that I do it to make it kind of come out, because those can be kind of tricky sometimes. So I'm going to write 1, 2, 3, 4, my set of domains, and now I'm going to write my set of ranges, or my y coordinates. There's my little colon, and then this one is 10, 10, 10, 10. So I don't write repeats, so my range is just 10. So all of these points fall along the same y coordinate, which makes it a horizontal line, if you wanted to know. It will be a function, but it didn't ask us that there. Okay, domain mappings may be something that you run into. I don't find a great use for it. I actually just like looking at the domains and pulling them out and deciding if things are a function. Domain mapping, or a mapping diagram, as sometimes referred to, is also a way to decide if a function, the relation is a function. If you happen to have a combination where one of your domains goes to 2 different ranges, that would fall under that bad vending machine if you've watched that video. Meaning that if I press -2, sometimes I get -1 and sometimes I get 2. Personally, I think this is more confusing than it's worth to arrange them, but for example, here are 2 sets of points that I've set up in a domain mapping for you. And again, you're just listing your domains in order from smallest to greatest. You do the same thing to the ranges, but now when you do the mapping, I'm going to say that -4 goes to 0. So I would draw a line from -4 to 0. And 3 goes to -2, so I draw a line from 3 to -2, and 8 goes to 1, so I draw a line to 8 from 8 to 1. And what this is supposed to show you is that if you get 1 like these red lines here, that 3 goes to 2 different locations, then it's not a function. The way we set it is if we see repeat inputs and it's not the same output, that's usually an indication that that's not a function, that it's just a relation. And that's what I'd rather have you do in my class. All right, let's take a look at another couple examples here. What happens if you're asked to find the domain and range of a set of points on a graph? Well, what you're going to do is you're going to find all the coordinates, both x and y, and you're going to list them in order. You can put them in a table, you can do them horizontally like we have in a set notation. That's really what we should have probably done here. I didn't do that, so let's do that really quick. -4, -2, 1, it's going to be crammed in there, 3 and 5. And then we'll do the same thing for the ranges. And again, I already put them in order in the table, so, well, at least for the x's. The y's I might have to rearrange. So there's a -1, we won't repeat that. There's a 0, there's a 2, and there's a 4. So there's the set of domain and range. The domains were in order, the ranges we had to reorder. Okay, so we took those points. If you were going to do it, this is what it would look like. You would list all of the coordinates on there, and again, you would put them into your table so that you had them nice and in order. So -2 here goes to 4, -4 that should be, and -2 goes to 1. We can already tell that this isn't a function because these are stacked and it doesn't pass the vertical line test. If you were wondering if it is a function, because we're supposed to say that. So this one was a function because we didn't find any of that. Sorry, jump back, forgot to do that. And then we're going to put 1 and 0 for this point here. We're going to put 3 and 3 for this point here, and 5 and -2. So again, writing the domains are going to be just these in order because we ordered them that way. So it's going to be -2, 1, 3, and 5. There's our domains where those can be found. So again, see what that means is, let's take a closer look at that because we have a visual. It means that if I look for this set of points that counts as a function, I know that I can find something on -2, I can find something on 1, I can find something on 3, and I can find something on 5. And for the ranges, that just means vertically where can I find them. So we did the domains, which means we're looking left and right. Now we're going to look up and down. We're going to look vertically, so I can find something at -4. I can find something at 1. Where's 1? There's 1. I can find something at 0, right there, this point, and find something at 3, and I can find something at -2. So what it tells us is all the locations on the y-axis. That's what the range is. So let's finish that question up. The smallest value is -4, then there's a -2, then there's a 0, a 1, and a 3. But this one is not a function, as we saw here, because these points stack in a vertical line. So that's what we're looking for there. All right, so let's move on to the last set of examples, which is the continuous function. So these are going to be lines or curves, not points. If you have to pick up your pencil, then it's a continuous function. Or if you don't have to pick up your pencil. Sorry, I said that backwards. So remember for this, that closed brackets indicate points that are included at the ends, and rounded brackets indicate open circles or points that are not included. And we can combine those, as you'll see. So what you want to do with this, okay, is you want to find your function, and then you want to find the end, and you'll notice that this end is open over here. So let's start with domain. Domain is looking at the x value. So what is the x coordinate? Well, you should really probably just list the coordinates of the ends of your function. Now, later on, we'll find out that these can have arrows and continue on forever. We'll deal with that in another video. But these ones do definitely end. This one ends here, has a nice open circle. So this coordinate point of this one is -5 and -5. You can see it here, -5 for the x and -5 for the y. And this coordinate point also ends, even though it looks like a square, ends at the x coordinate of 0 and the y coordinate of 5. So you list those. This is a simple one because it's a line. The leftmost point that it can exist in, right, that we can find this function, where it ends, the leftmost point. I don't care that it's down right now. I'm looking at how far left can I look on the x-coordinate, or the x-axis, and find it, which is -5. And it's an open circle, which means that it's going to be rounded, means that it doesn't include -5. So I would put for the domain a rounded circle, and then I would write -5. Now, on the next one, I'm going to look for the rightmost coordinate point for the x-coordinate. This is the x-coordinate, and this circle is included because it's filled in, so it's going to get a square bracket. So you can see I've highlighted those yellow. Those two in combination make the domain for this, meaning not included at -5, included at 0. And for the range, we're now going to look at the y-coordinate. The furthest down we can find this function is at this point here, and it is -5. And the highest we can find this function here is a y-coordinate of 5. So not included at the lowest point, so rounded, and included at the upper, so we'd write -5, not included, 5 included. Is this a function? Well, then you do your vertical line test, you draw vertical lines all over it, and it has to pass everywhere, and this one does, so it is a function. Okay, here's another example to look at really quickly. Again, I've identified a couple different of the coordinates of points on here. So let's look at the domain first. Remember, domains is x coordinates. So we're looking at x coordinates. So for this one, we're looking at this point and this point. Why these two and why not this one? Because this one's in the middle. This is the leftmost point that we can find, and this is the rightmost point for this function that we can find. So we're going to look at the left, write that first. -2 comes from this coordinate. That's as far left as we can find it with an x coordinate. And the farthest right we can find this function is this 2 here. Both are open circles, so they're both rounded. So we write rounded -2 to 2. And that's, again, the x-coordinate. So we're looking at this 2 and this -2 on the x-axis. So I'm going to switch my color. Now we're going to look at the range and define how far up and down we can find this function. So the lowest point we can find it is either of these two coordinates. They both end at -3, so either one works. They're both open, so they're both not included, so rounded. And the highest point then is going to be up here, which you don't know is the vertex, but is the vertex of this function, and it's at the y-coordinate of 5. So we're going to use the highest y-coordinate we can find, which is 5, and the lowest y-coordinate, which is -3. 5 is included because it's on the line, which means it touches it, so it will be a square bracket. So we write from -3 rounded to 5 squared off. And this one we can draw a lot of lines through and it be a function as well. All right, let's do two more. This one's a squiggle. That doesn't matter. It doesn't matter what the function looks like. What we're looking for is the leftmost point for the domain that it exists. In this case, it's an included -2. That's the leftmost point. So let's try to find and again, on the x-axis. So over here is the rightmost point we can find on the x-axis, and it happens to be a 4. So our domain is included there as well. So our domain for this one will be from -2 included, square bracket, to 4. And what that really means, and we didn't say this yet, is it means I can go all along here from these 2 points that I just referenced on the domain, and I can find the function if I look around. Yep, there's a function. I can look up, there's the function, look up, there's the function, look down, there's the function. Everywhere on that gap, this interval that I'm saying, I can find the function. That's what it's saying. So now let's switch colors again and talk about the range. So we're looking for the lowest point. Keep hitting that button. The lowest point then is here and here. They're the same. And the highest points are here at 3 and this one, they're the same. So both will work. It doesn't really matter. So our lowest point then for this is a -3 and it's included. Our highest point for this is a +3 and it's included. So we're going to be from -3 to 3. Meaning that if I am on -3 all the way to +3 along the y-axis, I can look over and see this function somewhere. And that's true. If you look left or right from those coordinates, you can look over and see that function. Again, we've defined everywhere this function is, left and right by the domain and up and down by the range. Is this a function? Sure. I can draw a whole bunch of vertical lines, and all they ever do is touch once. So yes, it's a function. And this last one then is a sideways function. You can already see that it fails. Sorry, it jumps out at me, so I got to talk about it. It fails, it touches twice. So not a function for this one. But let's talk domain and range. Just because it's not a function doesn't mean it doesn't have a domain and range. So the leftmost point for this one is this location here, which is 3 and 0. And its rightmost point is one's included here and one's open, but they're on the same vertical line. So we're going to go with included because it is ultimately included. One spot it's not, one spot it is, we go with included. Okay, so its rightmost point then for this one is 5, and it doesn't really matter for the domain because they're both 5, because that's what we're going to look at. So here's our domain. Leftmost coordinate for the x and rightmost coordinate for the x. And we said we're going to go with included. So this domain is going to be a soft bracket at 3 to 5, included. The range, and I'll switch colors again. The lowest most point is this one here, and it's an open circle, which means it's going to be -2 and rounded. Right? And again, we're looking up and down, y values. And the highest point for y value is this one here. So that's going to be this one, and it's included. So our range is going to go from -2 to 1 included, where 2 is not. All right, there you go. Watch the other video if you want a review of all those topics, but you've seen some examples on it, and now you're ready to do some in class. We'll see you there.